Hello everyone and welcome to day 4 of the 2024 Advent of Code. Today we're getting a grid problem, so let's see what this is about. We are basically doing a word search. We're trying to find Xmas in a grid of letters, and it can be horizontal, vertical, or diagonal, and it can be written backwards. So basically it can be in any of the 8 directions. So let's see how we go about this. What we can essentially do is we can go through every point in the grid, and then for each of the 8 directions, we can look for the next 3 letters in that direction. So what we're going to do here is first we're going to read in the grid, so we can do open 0.read to grab the entire input buffer at once, and then we can do .split lines to get it as a list of strings. So if we print out our testing data, that's what it looks like here, which works for our purposes. So now let's go through every coordinate in the grid. So R will represent the row index, so that will be in the range up to the length of the grid. And C will represent the column index, which will go up to the width of the grid, which we can do by getting the length of the first row. Now what we can do is we need to make sure that this is an X. So if it's not an X, then we can skip this case. Otherwise, we want to look for 3 letters in all of the directions. So what we can do is this. For dr, dc, which I will use to represent direction in row and direction in column, we can either move up, right, down, down left, or up left. Another way you can do this is you can do for dr in -101, for dc in -101. If dr and dc are both 0, then continue. It's up to you which way you think looks better. This is a bit faster to type out in contests though. And then what you need to do is verify that the endpoint is still within the grid. The way we can do that is by checking for r plus 3 times dr. We're going to move 3 steps in that direction, so this needs to still be in range, that range being at least 0 and strictly less than the length of the grid. And we also require the same for the column index, which needs to be less than the width of the grid. And so we can do, if that is not the case, then we also skip over this case. So now that we've made sure that our endpoint will end up within the grid, we can check the 4 letters. So the way we can do this is grid r plus dr, c plus dc. We require this to equal m, and the next one to be a, and the last one to be s. If this is all satisfied, then we can increment a count variable, and then we can just print the count to get our answer for part 1. For part 2, instead of looking for Xmas in a line, we're actually looking for MAS in an X shape. And so what we're supposed to find is 2 MAS in an X. The way we can look at this most easily is by looking for this A first and then looking at its corners. The way we're going to do that is a bit easier. Here we can iterate from 1 up to the length of the grid -1, and likewise 1 up to the width of the grid -1, because in this case, the A must not be on the edge, but that's the only condition. We don't need to worry about directionality. And the last one, the reason we went through all coordinates is because Xmas can start at the edge, in which case the number of directions we can search is limited. But here it becomes a bit simpler because we can just look at everything except the edges and corners. Of course, this must be an A. If that is not the case, then we can skip over this case. Otherwise, we can grab the corners, which we can do using up left, up right, down right, and down left. What we've done here is, given a letter A, we've grabbed this as the first in our list, this as the second, this as the third, and this as the fourth. The reason we go in a rotational direction is because the input can be given in any orientation, but most importantly, the M's must be adjacent and the S's must be adjacent, meaning we can't have the M's across from each other like this and the S's across like this, as the crosses then would be MAM and SAS. So what we can do here is we can essentially just check if it's MMSS, MSSM, SSMM, or SMMS. And so we can do, if we can join this on empty space to just get it as a string of 4 letters. This is a bit faster than writing out a bunch of equal statements separated by ORs, although that would be a bit cleaner maybe. But instead we can just check if it's in the list of search terms. And if that's the case, we can increment the count. So part B is a bit simpler than part A, at least as far as the coding in Python goes, but this is a relatively straightforward problem. Jumping back, because I forgot to explain this, one thing you do need to be careful for in the first one is making sure you do not double count. You have 2 approaches here actually. The approach I went with is always looking to start at the X and then going in any direction. Notably, if you have Xmas in any direction, you can't possibly double count it because you can only start on the X and go in this direction. The way I actually did it during the contest, which is a bit less clean, which is why I didn't show it in this video, is instead to look to start at either the X or the S. Essentially what I did was for each coordinate, I looked in 4 directions instead of all 8, and I looked for either Xmas in the forward direction or SamX in the backwards direction. This also avoids double counting because if it is lined up with one of the 4 directions I searched, then I can only find it from the X, as this direction will not be searched. And if it's lined up in a direction that I don't search, then I can only find it by starting at the S and looking backwards, because I will not go backwards in this direction. So that's just a thing to look out for. I believe the solution of looking in all 8 directions for Xmas is a bit simpler than looking in 4 directions for Xmas or SamX, but that's just my thoughts. In any case, thank you very much for watching this video. I hope you enjoyed, and I'll see you tomorrow.